When a body is in equilibrium under the action of 4 or more concurrent forces, a problem may be solved graphically by drawing the force polygon if there are no more than 2 unknowns, magnitude and/or direction, in your problem. This 650-foot television tower is held in place by 3 sets of guy wires located in vertical planes around the tower. Each 4-wire set is attached to a concrete pier. The resultant of these 4 concurrent coplanar guy wire forces is upward, to the right, and must be counteracted by a combination of forces exerted by the ground on the pier. Let's look at this example using the graphical method to solve this problem with 4 or more forces. The 4 forces acting at point B are in equilibrium. The magnitude and direction of F1 and F2 are known. F1 is 20 pounds and F2 is 60 pounds. The magnitude of F4 is known, which is 70 pounds. F3 is unknown, but the direction of F3 is known, which is 180 degrees. Find the direction of F4 and magnitude of F3 by constructing a force polygon. In tip-to-tail fashion, draw forces F1 and F2 from B to C and C to D. Through point D, draw a line parallel to the direction of F3, and around point B, draw an arc of radius r equals F1 equals 70 pounds. That arc and line intersect at point E. Force F3 acts from D to E, and force F4 acts from E to B. Measuring obtains F3 equals 52 pounds, and the theta, or the angle it makes, is 70 degrees. In the rectangular component method, each force is replaced by its x and y components. The resultant in the x direction, obtained by adding the x components of the forces, must add to 0. The resultant in the y direction, obtained by adding the y components of the forces, must also add to 0. In example 3.6, the 3 forces in figure 3.25a are in equilibrium. Determine F1 and F3 by the method of rectangular components. The x and y components of each force are determined by trigonometry, as shown in figure B and tabulated in table A. From table A for equilibrium in the x and y directions, we write the equation A as the summation of fx equals 0. So, negative 0.5000 times f1 plus 0.8660 times f3 equals 0. For equation B, the summation of fy equals 0. So, 0.8660 times f1 minus 5 minus 0.5000 times f3 equals 0. From equation A, f3 equals 0.5000 divided by 0.8660 times f1 equals 0.577 times f1, which is equation C. Substituting the value of f3 from equation C in terms of f1 in equation B, we have 0.8660 times f1 minus 5.0 minus 0.5000 times 0.577 times f1 equals 0. f1 equals 8.67 kip. Substituting the value of f1 into equation C, we write f3 equals 0.577 times 8.67, which equals 5.00 kip. So, if you go back and substitute f1 and f3 into equation A, and if you find your equation is equal to 0, that means you have the correct answer.